So today we are going to discuss the multivariate analysis. Basically, what is meant by multi mean poly or multi, and variate is which means variable, and analysis mean to find out the relationship, right? So multivariate analysis, just for example, if we take an example of lung cancer and we want to analyze the relationship of smoking, what is the effect of smoking, and what is the relationship of smoking that can lead to cancer. So basically, if the lung cancer can is also associated with age, it is also associated with occupation like asbestos exposure, and it is also associated with radiation, prior radiation history. All right, so if a patient of lung cancer come to you, then you have to take multiple variable into account, like especially, is the patient smoking? Yes, if this patient is smoking, he's at high risk, but you have to consider another variable as well. Is the patient aged above 50, 60, and 70? As the occupation is also the patient is also smoking, along with is he working in some asbestos or pipe industry, and does the patient has any prior history of radiation? So if we want to analyze the find out the relationship between smoking and lung cancer, then we know that there is a direct association of smoking and lung cancer. But as the smoking rate increases, the risk of lung cancer will get increases. But in term to get this relationship, we need to count this we need to take this age, occupation, and exposure, and prior radiation as the same for the group of patients, right? So this is the multivariate analysis, to take into account multiple variable at the same time for the same effect or outcome. So basically, it has two types. Number one is the uh, logistic regression, and number two is the linear regression. Now, what is logistic regression? Which is used in models assessing a dichotomous outcomes, like alive versus dead, having a disease versus not having a disease. Logistic relationship in which there are the outcomes are dichotomous. So dichotomous outcome or variables like a patient is alive or dead, or versus we can also take an example of does the person or sample is having the disease, or they do not have any disease. So disease or patient on disease negative patient. So it's like these are the two dichotomous relationship variables. So if we are having such dichotomous relationship, for those methods we can use logistic regression. That is an type of which is a type of multivariate analysis, logistic regression for dichotomous alive versus dead, disease versus non-disease. We can take take an example of patient shall go to high school, or go to high school versus not going to high school. So these are some terms, like not going to high school. Like for example, if we take such example or such sort of data in which there is only two dichotomous models, and which the outcomes are just two, yes or no, dead or alive, admitted or non-admitted, disease or not disease. For that analysis, we use the logistic type of regression. So basically, the logistic regression can tell us about categorical data. It is showing us the categorical data, and it answers, it finds out the relationship between the outcomes having in the form of yes, no, true, false, disease, non-disease, alive, dead. And we can also say that a 0 or 1 in computer, right? So if just taking an example of anything, like if we divided our 100 patients to disease versus non disease, non disease, and we take we make a bar graph, like these 50 are having the disease, right? And we make another bar graph, these 50 are not having the disease. So if we want to compare the relationship between two these variables, and want to find out the relationship between this, it will be answered is by a logistic regression. Now, in multivariate analysis, once the logistic regression is used in models having a dichotomous variables, after that there is a linear regression. Linear regression is used in models assessing continuous outcome. It is used in models having continuous outcomes, right? Like if we take blood pressure relationship with uh, captopril, right? So it with this will show us a linear regression, right? How? Like if we take an example of a high blood pressure patient is having 150 by 100 bp at this point, and we haven't given any captopril tablet, right? This is 0, and here we take the blood pressure on the y-axis, and we take the captopril on the x-axis. This is the one tablet, this is the second tablet, right? So if this patient takes one tablet, then the blood pressure will fall down to this point, which at this point it will be measuring around 130 by 90 millimeter of mercury, right? Now, if this patient takes another tablet after 20-30 minutes, this blood pressure will fall down further, and at this point we measure the blood pressure, it will be around 110 or 70 millimeter of mercury. So it's this graph shows us a linear, a continuous variable. The change in blood pressure is inversely proportional to the captopril, right? So if we increases the captopril, the blood pressure further down in a linear fashion. So it is this is also a continuous fashion, and this is also in a continuous fashion. So if the model having variables or outcomes in a continuous fashion, we will use the linear regression format. Another thing we can example is the height versus weight in a person. As far as the person height increases, like at 100 centimeter, the patient is having 50 kilogram of weight, but once the person is having 150 centimeter, the weight increases into the 75. Like it's the same this in this patient, in this fashion, which the data is in a continuous 50, 51, 52, 53 continuous outcome variable, and they are like just like in the height, which is also 100, 101, 102, and it is also in a continuous outcome. So when the data set or the models, we need to assess or find out the relationship in which they are in a continuous outcomes, then we will use the linear type of regression. Now we are going to discuss the time to event analysis. We also call it a survival analysis. In survival analysis are discussed in two terms, in two types, like Kaplan Meier analysis and Cox proportional hazard ratio, or we can also call it Cox proportional hazard analysis, right? So basically, time to event analysis or survival analysis, many example of medical research deal with an event that may or may not occur in a given time period. Like we can say that we are dealing with an event that may or may not occur within a specific time period. Like if we take a time period for our experiment from 0 to 10 months, and we want to know that out of these 100 patients, how many patients will get stroke, how many patients will die, and how many patients will have an MI if we give the drug X to this patient, this number of patients, right? So there is a possibility that the patient may or may suffer from stroke, death, or MI, unfortunately. But there is also a possibility that this patient might die of diabetes mellitus, which is not a variable of our experiment, might die of a road traffic accident, or might die from asthma or drug abuse, right? So for this type of event analysis or survival analysis, we can take help of time. Like the more we observe, increase the time for observation, the more accurate is our data. And we are using the most commonly used methods in medical research, which are Kaplan Meier and Cox proportional hazard analysis. So basically, what is Kaplan Meier? Kaplan Meier analysis is the ratio of surviving patient in total number of patients, right? So in every time patient has an outcome, so the ratio is recalculated. Basically, in Kaplan Meier analysis, we can take an example of patients, 100 number of patients, and we take the time, and we say like this is the 5 years, what happened at 10 years, and what happened at 15 years of follow-up. So we do this in a prospective cohort study, right? So if we find take an example of 100 patient, and those are 50-year-old patient, and we see that this patient after 5 years only 50 of patient has remained, and after 10 years passing, only we saw that only 25 of patients have been remained. After 15 years, only 5 patients have been are surviving then, right? So this is the Kaplan Meier analysis without intervention. Now if we intervene in this patient, and we use a drug, and this and there are and then after the use of the drug, there is a possibility that it increases the survival of these patients, right? Now in Kaplan Meier, if we use a drug, this is the a graph after using the graph of surviving curve after the intervention of drugs, right? So we saw that if this is no drug and this is the drug group, so if we look at this patient after 5 years, there were only there were 80 surviving patients, right? And 20 patients have died. Now after 10 years, we saw that there are around 65 patients who are surviving with the drug intervention. So we saw we are comparing that without drug intervention, the survival at 10 year of follow-up was only 25, but with drug intervention we saw that the survival has increased after 10-year follow-up to 65. So comparing these two groups, drug versus non-drug groups, group 1 and group 2, and we after 10-year follow-up we saw that in non-drug group only 20 people are surviving, and in the drug group only in drug group we saw that after 10 years there were 65 people surviving. By comparing these two groups, and we call this survival analysis simply as a Kaplan Meier analysis. Once the patient dies, there is recalculation of this data. Mean at this point or 20 patient have died. Now from this point onward we will recalculate from, and the graph will go down, right? And every time patient has an outcome, the ratio now of the total number of patient surviving to the total number of patient taken will be recalculated in the Kaplan Meier analysis. Right now we come to the Cox proportional hazard ratio, in which there is a comparison of the logistic regression or dichotomous values, right? So in it uses the logistic regression. Second, it uses multiple variables, right? In Cox Kaplan Meier analysis, we have used only the drug versus non-drug. This is the same one variable, and in log Cox proportion there are multiple variables we are taking, and we are using the logistic regression, in which there is the outcomes are stated in a dichotomous type of outcomes, like we, as far as we remember, the answer were in yes in no form, the zero in one form, and the past and failed form, and we can also say the disease and non-disease form. So in logistic Cox proportional hazard ratio, we if we take the survival analysis, we will have multiple graphs, right? In Cox proportions, the survival analysis is best like just if we take an example of a lung cancer patient, and we are giving the drug, just like we take an example of the drug Primitrexid. We can take an example of Primitrexid, which is a anti-cancer drug in lung non-squamous cell carcinoma, right? So if we take two groups, like just group A and group B, right? Now this we take 100 example here, and we take 100 in example up here. So in the group B we have given the Primitrexid, and in group A we have given a placebo. Now we will analyze them at 5 year of age, at 10 year of age, and 15 year of age. Now if in lung cancer, we will see that the patient who are receiving the drugs, who are receiving the who are not receiving the Primitrexid, will be having the graph shifted to the left side, and the patient who are receiving the drug, the graph will be shifted to the right side, right? These are the Primitrexid group, right? And these are a non drug used group. But if we see that the Primitrexid and the we compare the patient having the advanced stage, like stage 4 disease, the graph will also be shifted to this stage. So we can compare it like these are the graph will also be in the patient are receiving Primitrexid, so the graph is also shifted to the left side. We saw why because in this patient, the second variable we have taken is the stage of, so the stage 4 this patient will also be having the curve more to the x-axis, right? So it means that their survival rate will also be low. But if we take another variable, like in Cox has a proportional hazard ratio, we take multiple variable: age, stage of disease, drug intervention. We take multiple other variables as well. So in Cox proportional hazard analysis is just similar to the logistic regression, because it counts for many variables that are relevant to the predicting the outcome of a dichotomous variable. Just however, unlike logistic regression, Cox proportional hazard analysis permit time included as a variable, and for patient to be counted only for the period of time, right? So in Cox proportional hazard relationship, there we take a period of time as well in the proper variable. So the summary estimate generation, just like we can say, I told you that here we take multiple variables, just like age, stage, we take the drug intervention. We can also use the sex as another variable. So in Cox proportional hazard ratio, we used multiple variable. We have drawn multiple outcomes as well. So just like if we take the prematrixate group, but the patient are having above 70 or 80 years, so their ratio will also be left shifted to the left side. So in the Cox regression, so the age is greater than 75, and then the such patient, the graph will survival will be also survival analysis will show us more death ratio, more death ratio, even if drug intervention, even if drug intervention is present, right? So in Cox proportional Cox proportional hazard analysis or ratio, we are having the multiple variable and we analyze them, just like we are using having a specific time period as well in the Cox proportional hazard ratio. That's it.